So taking some good notes now will help you write a much better introduction. And so the first job that you have is you need to understand a concentration gradient and how it will cause substances to move in and out of a cell by something called passive transport. And today is here's your topic. Here are two of the things we're going to talk about with passive transport today. And here's the date. And here is what you need to be able to do by the time we're done talking. There's some terms that are important for you. I expect that you are able to share with a friend what those mean by the time today is over. A lot of words in there. I'll show you what they are. We'll be investigating this in some pretty good detail next week. So we'll give you a short introduction today, a little bit more tomorrow. Friday, you're going to go back to a little activity on endosymbiosis and why is it a theory and not a hypothesis or a law or a fact or anything else. So passive transport, osmosis, and diffusion. Concentration gradients. Show you an example of one, and we'll talk about another example of one, and then we'll go put your stuff on the wall. I have a beaker of tap water here. I have some dye here, courtesy of some tie dye that Mrs. Jordan let her fourth period, her Spanish 4, do for Day of the Dead next week. I all those stuff for Day of the Dead or pumpkins. Yeah. So they tie dyed yesterday in here, yay. And this is pure water. So the concentration of dye in this pure water right now is 0 all the way through. Okay. If I add a drop or two of dye to this water, we have what we call a concentration gradient. The concentration is high in some places and low in others. Does that make sense? Which direction is the dye going to move? It seems to be going down, but eventually what's going to happen? Sure, because it's going to go from a high concentration area to a low concentration area. So if we let this sit for a little while, you're going to see that that dye spreads pretty well throughout that whole beaker. So that is the concentration gradient. You okay with that? There's high concentration of something and low concentration. Okay. Let's look at how that works with something you might be familiar with, iced tea. Who likes iced tea? Who only drinks it if it's sweet? Yeah, okay. So here we have, and just draw the blue stuff first. We have two glasses of iced tea. Okay with that? Maybe watch first and then let you drop. Two glasses of iced tea. Here's one of them. Here's another. Okay. In one of them, we put 6 teaspoons of sugar. In the other, we put a half a teaspoon of sugar. Which solution is more concentrated? The one with 6 teaspoons of sugar or half a teaspoon? With 6, yes. 6 is much more concentrated. Okay, so eventually, the sugar is going to dissolve and it's going to spread out. Okay, so go ahead and draw these guys now. Draw the first two and label. But the first two, you're seeing that we have some terms here that I hope you remember. Sugar is the solute and water is the solvent. Do you remember those terms? Okay, good. Sugar is the solute, which means it dissolves in water, which is the solvent. The solvent does the dissolving. As the sugar dissolves, here's what happens. At first, when you dump it in, there's a big concentration of sugar at the bottom. You've all got that friend who puts the 6 or 7 or 8 teaspoons of sugar in their iced tea, right? Maybe it's you. I won't ask you to confess to that. But there's a big concentration of sugar at the bottom, and as they and less of a concentration at the top. As they stir, they help it dissolve, and the sugar then disperses throughout the iced tea, so you get the same sweetness at the top as you get at the bottom. So we have a greater concentration and the lesser concentration. This is with our beaker full of dye. If you didn't do anything to this and you let it set for a day or two, pretty soon that sugar would dissolve on its own because the water molecules move on their own. And the sugar would disperse throughout, moving from a higher concentration to a lower concentration. So think about that particles move from higher concentration to lower. Go ahead and draw. Oh, you see another term that we can use to compare these two solutions. This is kind of important as well. If you know someone who is hyperactive, what do you know about what do you know about them? Why are they hyperactive? Sometimes they might have eaten a lot of sugar. But what is the difference? If you didn't know what they ate and you were just looking at two people, how would you know one was hyperactive and one maybe wasn't? What would one be doing? Yeah. A lot, yeah. Yeah, little kids, you say, oh, they're bouncing off all the walls because they're excited about something or they've had too much sugar. So if something has a lot of activity or a lot of solute, we say that it is hypertonic. Hyper means more. if someone you may have heard someone once say this, I have hypoglycemia. Has anyone heard that? Someone said hypoglycemic. You heard that? What does it mean? What are they saying about their own health, their own situation? Glycemic is sugar. Someone's hypoglycemic, they have low blood sugar. And you might be told not to do that before you compete in an athletic event. You might be told to eat a lot of carbs so that your blood sugar stays level and you can have the energy to compete. So hypo means less. So between those two glasses of iced tea, you have one that is hypertonic, which means it has more of the solute. It's more concentrated. And one is hypotonic, the one that you didn't put much sugar in is hypotonic. Now, in those two glasses of iced tea, there can't be any movement of particles because they're two separate containers. So the sugar or water can't jump from one to the other. If you put them in the same container, like we did the dye, we still have a concentration gradient here. We still have a lot of dye at the bottom and less at the top. It's starting to move a little bit. We call that movement diffusion. Dye is starting to move. We call that movement diffusion. Diffusion will move out that concentration gradient. Right, we'll look at one more thing. This wagon rolling down a hill is showing you what happens in a concentration gradient. The solute, which is the truck, the wagon, will move from high concentration to low concentration, just like something rolling down a hill. This is how the concentration gradient in your iced tea, when you put in the sugar, or in this beaker of dye. Okay. If I let this sit here until tomorrow, you'll see that it's all going to be pretty uniform. That's how the particles move from one spot to another. They go from the high concentration, which is in the iced tea, or in this beaker at the bottom. They will just kind of gradually, because of the movement of the water molecules, because they're not staying in place, they'll gradually work their way up to the top. Now, how does this relate to what you're going to do in lab next week? Here's it in a nutshell, an overview. You're going to have a beaker or plastic cup in which you're going to put a solution, and you'll have some choices. You're going to put inside of a piece of dialysis tubing. Dialysis tubing is what's used in when people get kidney dialysis. Have you heard of someone getting kidney dialysis? Their kidneys aren't working, and so you go into a clinic and they hook you up to a machine and they filter your blood through a machine. And that machine contains a membrane that puts the good stuff in and leaves the bad stuff out, which is what your kidneys do. But if your kidneys aren't working, you need some help. So you're going to use, it's just like, it's almost like a baggie kind of stuff, like saran wrap. And you're going to make some choices. In this case, there is a lot of some kind of substance in here, all the little particles. And there are only a few of them outside. So this solution inside is hypertonic. It has more solute. Outside, there's less. There's mostly water with just a few particles. It's hypotonic. The solution itself will tend, both solutions will tend towards an equilibrium, which means they have equal particles in them, equal concentrations. So to do that, some of the water has to get in and or some of the particles have to get out. So the water is in higher concentration out here. A lot of water, few particles. Whatever the particles are higher concentration inside dialysis tubing. So the particles inside could move out. The particles outside, the water outside could move in. Is that sitting okay in your head? Do you have questions? We're going to spend some more time tomorrow looking at that in a little more detail and figuring out what you might want to do in that lab next week, because you're going to choose what you want to put inside and what you want to put outside. And then you're going to see if what you thought would happen happens, what's going to move in, what's going to move out. We need to know a little bit more about the membrane first. So think about what all of those channels, what they might do. We'll look tomorrow a little bit more about how water goes in and out. Think about what these channels might do and what might go out in what way, and consider what your fake cell membrane actually has and what can happen. So what we want to do now is we want to go outside, put hangers on the wall. And you want to be kind of socially distanced while you do that. And I want to turn off the recording. Okay, so a couple of you can come on out here. Let's hang you out. I can't see this. So you're noticing any kind of pattern where all these things are located? Spaces close to each other. how your natural things are in your cell membrane. They don't have any set place in the house. It usually will be quite as crowded as what you see. Hopefully be a little bit farther apart. Some of them are all the one side of the side probably recording when we're done. I did want to stop recording.